Okay, now that we've seen how to calculate reaction rates at average time, based on we did the molarity calculations here, M1V1 equals M2V2, and then we also did reaction rates by taking molarity of iodine divided by the time, the average time. So, which is right here that I did for my set of data. Yours might be different, okay? So I have all my rates here. Now I can take reaction mixture 1, 2, 3, 4 molarities and the rates to help me calculate the order for each of these reactants here. So I'm going to go ahead and start with acetone. For me to find the order of acetone, I need to find two reaction mixtures, okay, two of these lines that only acetone is changing, but HCl and iodine are constant. Okay, so HCl and iodine cannot change, but acetone has to change. So just by looking at it, we can see that if you take lines 1 and 2, you have 0.8 going to 1.6, 0.2 constant, 0.001 constant. So that works. Lines 1 and 2 would work for acetone. Say someone said, well, what about we use lines 2 and 3? Can we use that? Well, I wouldn't use lines 2 and 3 because yes, acetone is changing, but HCl is changing also. That's not good, okay? And iodine is not changing. So you need to have only one thing that changes and the other reactant stays constant. What about we take a look at lines 2 and 4? Lines 2 and 4, we have 1.6 and 0.8. Okay, that's changing. That's 0.2 and 0.2. That's okay. But now you see here my iodine is changing too. So that's going to make my life difficult. I want to pick lines where only two things are, well, only two lines where only one mixture, one reactant is changing and the other two are constant. Okay, so in my case, I'm going to pick lines 1 and 2. Now, when we pick lines 1 and 2, I like to write, basically, you can write the rate order. So rate for rate 2, okay, equals to 1.98 times 10 to the minus 5, agree? We can put that down here. And then equals to K, because rate equals to K, rate constant, times molarity of acetone, right? So I guess I'll go ahead and write the formula up here. Rate equals to K acetone to the power of M, H plus to the power of N, we'll do N here. And then we'll do iodine, I2 to the power of P. We'll do P here, okay? So we have that here. Now all we want to do is go ahead and plug that in. So you see how I put that rate here for line 2? So I'm going to put the molarity for line 2 there. So 1.6 to the power of M, 0.2 to the power of N, and then 0.0010 to the power of P. That's rate 2. I'm going to write rate 1 right below it. Okay, and rate 1 is 9.85 times 10 to the minus 6 equals to K. The first one is 0.8 to the power of M. Then we have 0.2 for HCl to the power of N. And then iodine is 0.0010 to the power of P. Now, if you take rate 2 divide by rate 1, you can just do this whole thing divide like that. You can see that you can get into a number. And then K cancels off, this cancels off, and that cancels off because it's exactly the same term. So now what I end up with is 1.98 times 10 to the minus 5. Okay, I'm going to take that and divide it by 9.85 times 10 to the minus 6. So my answer here is going to be, well, 3 suffix would be 2.01, really close to 2, okay? And then what's 1.6 divided by 0.8 here? That can actually turn to be, if you have this term here, that can be rewritten as 1.6 divided by 0.8 to the power of M, okay? And that right there will be 2 to the power of m. Agree? So 1.6 divided by 0.8 is 2. So now you have to figure out how can I get how can I solve for m, because m here is the order of acetone, and then we'll do the same for HCl and iodine with different lines here. So your goal is to pick the correct lines. If you use the wrong lines, you won't be able to cancel off certain things. Your goal is to cancel off 2 of them, leave one that's changing, and then we can do this log calculation here. So to solve for m here, I would just take log on both sides. So log 2.01 equals to log 2 to the power of m. And this becomes m log of 2, and this is log of 2.01. Obviously, I'm running out of space. I'm going to be doing the orders for the other ones separately. But you can also take a look at step 3 calculations right here on page 8 of that manual. And then you go over here, they actually walk you through example calculations right here. So here's an example that they show, the one I just wrote here, rate 2 or rate 1 and all that kind of stuff. Okay, so pay attention to it. That will be very helpful for you guys. Just read through it carefully and gives you an example, but here's an example anyway. So now we want to solve for m. M is going to be log of 2.01 divided by log of 2. So let's do that on our calculations. What did we get? I got 1.007. So, I mean, obviously it's just 1. So I'm going to round the order to 1. So that means the order of acetone is 1 in this case. Okay. So when you write a rate law, you have one piece of it. Your rate law would be rate equals to K, and then you know acetone is order of 1. Now your job is to find what the order of this guy is, H, which is going to be power of N. So we have to solve for N to get this, and then we also have to solve for iodine to get whatever that order is. That would be P. Okay, so your job is to pick 2 lines. So if you wanted to solve for H here, for HCl, you have to pick 2 lines where you can have HCl changing, but acetone and iodine cannot change. So if I just take a look here, well, 2 and 3 can't be used because this one's changing 1.6 and 0.8, so I don't want to do that. That's changing, yeah, but 2 things changing is a bad idea. Only 1 thing changing, okay? So let's take a look at maybe, well, we did 1 and 2 earlier, so that can't work, 2 and 3. What about 3 and 4? Did we take a look at that? That one's changing, constant, that's good. That one's changing, but that one's also changing, so that's not going to work. What about 1 and 4? That's not changing, so that's not going to work. 1 and 4, you need HCl to change, so you don't want to do that. Let's do 1 and 3. Let's take a look. 1 and 3, so this one's constant, 0.8 to 0.8, that's good. HCl, is it changing? Yes, 0.2 going to 0.4, that's good. And is my iodine constant? Yes. So I would use lines 3 and lines 1 for HCl. I would do that. And I would just write rate 3. So with the rate here, 2.06, 10 to the minus 5. And then I write the K, and then I put in the molarities of all my Ks for my line 3 right there. So let me go ahead and switch pages. We'll do that together. Obviously, your data is going to be different. So you'll have to do your own set of calculations, but this is how you would do it, okay? Change page. Let's do it on this paper. So I have lines 3 and lines 1. So what I'm going to do is just go ahead and copy down the rates. So my rate was 2.06 for the 3rd line. I'm just going to copy all of this down for rate 3. Okay, so rate 3 equals to K, and then acetone. I know that was to the power of 1 already, but now I got to find H plus to the power of N, and then I2 to the power of P. So I'm going to go ahead and write that out here. So rate 3, the rate 3 would be 2.06. times 10 to the minus 5 equals to K. Acetone is 0.8 to the power of 1. See how I'm just writing that down here? So I can move it up so you can see. So you just copy it down, 0.8 and then 0.4 to the power of n, and then 0.0010 to the power of p. And then I'm going to write rate 1 right below it because I decided I was going to use lines 3 and 1, remember? The reason why I put 3 on top of 1 is I like to put the bigger one on top of the smaller one. You don't have to, but it's just the way I like to do things. That way I have a big number on the top, okay? So I'm going to put the rate for 1 up here. So this is rate 1, okay, right there. So 9.85 times 10 to the minus 6 equals to K. And then line 1, it was 0.8. I already know what acetone, I can just put in order 1 there. And then 0.2 to the power of n, and then 0.0010 to the power of p. See how that cancels off because it's identical? That cancels off, that cancels off. Now I have that, which then that turns into 2.0 to the power of n. That equals to whatever this answer is. So let me go ahead and do that on my calculator. 2.06 times 10 to the minus 5 divided by 9.85, 10 to the minus 6. I got 2.09 in this case. So then I go ahead, I want to solve for it using log, put log on both sides. Okay, and then we do the same way like we just did. So now we take n here, log 2.09 equals to n log 2.0. So then we have n equals to log 2.09 divided by log 2.0. That should give me the answer of 1.06. So round it up to 1. So now I know the order of H plus is also first order. So the next piece of my rate law is figured out. So I know this is first order. I know now this is also first order. So let's fix that and say, I know this is also first order. Okay. So first order. Then your job is to find order for iodine. So for iodine, you have to pick 2 lines, okay, where only iodine is changing. HCl cannot change and acetone cannot change. So earlier I accidentally picked it. I saw that if I took line 1 and 4, if you notice, line 1 and 4 is 0.8 and 0.8, that's good. And then 0.2 and 0.2, that's good. It's not changing, that's what I want. But I want my iodine to change. And yes, my iodine is changing here. Okay, so I'm gonna put rate 4 over rate 1 and find the order of iodine here. So hopefully you guys can follow this. I'm just gonna work it with my numbers. Remember, your numbers are going to be different, okay? So depending on what your numbers are, your orders may be different, your rates are different, but the same way to do it. So you just gotta be careful with picking your correct lines. The key is to pick only ones where the one you're after is changing, everybody else is constant. So I'm gonna do lines 1 and 4 for my case here, okay? So lines 1 and 4, I'll write rate 4 over rate 1, basically, okay? I'm just gonna write it all down here like what I just did earlier for this example up here. So rate 4 from my chart is 1.01 10 to the minus 5. Just keep in mind your number will not be the same, okay? Okay, my that equals to K. And then I already know my acetone. So let's go ahead and put my acetone is. 4 is 0.8 to the power of 1. And then I know my HCl is 0.2. I'm just writing that down from here. 9.4 at 0.8, 0.2, and 0.005. 1, 0.00050 to the power of p. I don't know what that is. I'm looking for that. And then rate 1 is 9.85 times 10 to the minus 6 equals to K. And then 0.8 to the power of 1, because I'm copying it over from here, 0.8, then 0.2 and 0.001, okay? The power of P. Now, if you notice, then we can still cross off all these things. Cross this one off, cross this one off, cross that one off. Now you have this left over. So let's find out what this value is. 1.01 times 10 to the minus 5 divided by 9.85 times 10 to the minus 6. I got 1.025. Okay, and then what does that become? So 0.0005 divided by 0.001, I get 0.5 here to the power of P. Okay, so now I have to solve for P. I'm going to take log of both sides. Log of 1.025 equals to log of 0.5 to the power of P. And I'm going to bring the P to the front. So rewrite this. Log 1.025 equals to P log half. Okay, and then P would therefore be log of 1.025 divided by log of 0.5. Right there. So I'm getting a negative 0.035 number here. So with this number here, what's the closest number? 1, 2, 3, 0, or negative 1? Obviously, it's 0. It's the closest, right? So I'm going to round this to 0. Therefore, my order for iodine here is 0. So now I know my answer for my rate is all the orders are there. So for this one here, you're like, oh, I know the answer now. This one says 0. Okay, so that's how you would be able to get your answer here. So just remember, when you get the answer, you always round to the closest order, the number next to it. Okay, so that's how you would do the orders. And now the next thing, if you want to solve for the K, we'll go ahead and work that out here. Now, based on what your orders are, I got 1, 1, and 0, but you could have gotten something different. I'm just going to go forward with mine as 1, 1, 0, and I'll show you how I can calculate the K. And you can repeat it for 2, 3, and 4 and get the average K. Keep in mind, because these are all the same temperatures, the K for these guys should be similar. If they're different, you may have had either an experimental error or maybe calculation error here. Should be similar, okay? So to get the reaction mixture case, all you do is literally write down the rate from here and then plug in the orders and the molarities in here, okay? So for the first one, okay, for the first K, I'm gonna write down, I guess I could zoom out a little bit more. Just scoot my camera right there. You can't see that. 9.85 10 to the minus 6. Okay, I'll write it down. 9.85 times 10 to the minus 6 equals to K. The first one, I'll just write K1 so you know. And then acetone was 0.8 to the power of 1. Now, I'll go ahead and write down with the units, that way you can see. So this here is molarities per second, and then this is molarity. And then we have 0.2 molarity to the power of 1. And then we have 0.0010 molarity to the power of 0. Lucky for me, anything to the power of 0 disappears, turns to 1, so I can just drop that term completely. Okay, if you don't have a power of 0, then you have to keep going with all those numbers on there. So now what I have is anything to the power of 0 is 1, so that disappears. Now I gotta do the calculations here. So this is 9.85 times 10 to the minus 6 molarity per second equals to K1. These two terms here is 0.16 molarity squared. Okay, so K1 would be 9.85 10 to the minus 6 divided by 0.16. Obviously, your numbers will be different, so make sure you're checking your work, writing down the correct numbers. I got 6.15 So it's really 6.2 times 10 to the minus 5 molarity. So this is, so the units here are m divided by s and then divided by m squared. Okay, so that's how I know my unit is m minus 1 because m and then divided by m minus 2. So get m minus 1 here and then s minus 1 right there. That means these two are on the bottom divided. Those are my units for my K. So you just continue with rates 2, 3, 4. Put in the same numbers from your chart here. Rate 2, molarity, 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 and the orders in there, and then solve for your K. Do the same thing here. So one common error is sometimes when you're trying to divide, if you don't get the product of this first beforehand and you try to do it all in one step on your calculator, you need to be careful because the calculator can accidentally, if you just typed in this, okay, so let me show you what would be a common error here. 9.85 times 10 to the minus 6, and then you tell your calculator divide, right? You have this number in there. You told it to divide by 0.8 and 0.2. Okay, so what I would do here is if you just type that in here, like some people just put a multiply sign here, right? So what the calculator actually does is take this 9.85 10 to the minus 6 divided by 0.8 and then the answer times 0.2. So to prevent that, you can do a big parentheses on the outside here. So you just make sure you do the product of it. Okay, so just keep that in mind when you're doing calculations. Double check yourself and always check with me too. I can help check your calculations for you. So once you get your K here, your average K will go here. Whatever your average K is, we will be using that for part B. So you'll need your order solved correctly with the lines picked correctly and your average K before we can start on part B. So this is the end of part A.